you like my t-shirt? I know to the untrained eye it may look unironed, but this is actually high fashion, so deal with it. That's what happens when you pack in a suitcase. So, decision making. Speaking of decisions, anyone make any bad decisions yesterday? Last night, maybe? Anyone went to bed at 9 o'clock? 10 o'clock? 11? 12? Oh, some party ended. 1? Oh, 2? Oh, 3? You can't see, the live stream can't see this, but people are still raising their hands. 4? 5? I'm just going to continue because someone's bound to be 6. 7? Did you sleep? Anyone no sleep? Okay. All right, well, I hope you had a good time yesterday. That's all that matters. Let's talk about decision making. Of course, decision making. Let's first ask our AI overlords whether we still actually need to bother with all this. Is that readable? Can people read it in the back? Sure. All right. Well, luckily they say that we still have to make decisions on our own as developers. So that's a good thing. We haven't lost our jobs just yet. Just a matter of time. So, does anyone know what this number means? Anyone take a guess? 35,000. Airplanes? Oh, okay, well, today I learned something. You do realize this is not an airplane talk, right? All right, cool. Anyone else want to have a guess? 35,000. I'll give you a hint. It's relevant to the topic of this talk. Yeah, you wouldn't have guessed. I know. No one from 3 AM that wants to take a shot at this? Oh my God, there you go. Did you Google it or? Okay, I saw you holding your phone. I wasn't sure. Yeah, so 35,000 decisions in a day. I find it kind of hard to imagine that someone actually sort of was able to measure that, because what exactly is a decision? We're not going to go into that complicated topic, but obviously this includes like the larger decisions, like you deciding to come to this conference, but also small decisions like what are you going to wear today, what are you going to eat, and so on and so forth. In this presentation, I want to go through this process a little bit. I want to dissect it just a little bit, give you a little bit of the psychology behind this, and then we'll go on to learn about some techniques that you can apply in your day-to-day job or day-to-day life. But let's talk about cars first. Anyone know what model car this is? A red one. Okay. Thank you. Yes, it's indeed a red one. But it's also a Corvette. Let's call it a red Corvette, yeah? I'm not really sure why I'm showing you this. I guess I'm sort of manifesting this car into my driveway. It'd be nice. Don't even have a driveway, so I'd first have to get a house with a driveway, but sure, whatever. I have some time left still. But I enjoy driving. I think driving's fun. I drive to work almost every day. Well, Monday to Friday. I am free on the weekends. I live about 15 to 20 minutes cycling distance from my job, so when the weather is good, I live in the Netherlands, so that's never. I'll actually cycle to my work. But yeah, driving is fun. Do you recognize that feeling when you're driving on the road and you arrive at your destination and you're like, how the frick did I get here? I have no recollection of what I just did. Were the lights even green? Sort of afraid to look behind you, just see chaos, cars on fire and everything. People crashed. You're like, oh, everything's fine. So this is actually called highway hypnosis. It's not as scary as it sounds. It's sort of okay. Like your mind is in sort of almost like a flow state. It's relaxed. It's sort of focused. Maybe you're thinking about different things, but when something happens on the road, it's still, you'll still be alerted and you'll still act on it. So it's not too bad. Now, when you first start driving the car, you don't experience this highway hypnosis. You're like, okay, I gotta get in the car. push on the clutch, put in the first gear, your first driving lesson. You don't want to stall the car because your friends and family are watching, so it's very embarrassing. So you drive off, like, oh, phew, I did it, all right. Then you arrive at your destination, then you forget it's still in the first gear, you let go of the clutch and stall the car. Anyone here stalled a car before? Way too little hands. No way. Absolutely, you're a liar. Absolutely not. Unless you drive automatic, then I guess, but no way. So that's a very different experience as opposed to a more experienced driver where you just get into your car and everything's sort of automatic. It's muscle memory. You don't really have to pay it. Well, you do have to pay attention, but you don't really have to, pay attention to everything that you're doing because you're used to operating this car. And you have the same thing for developers, right? A beginner developer is still very much focused on things like syntax. How am I going to translate these requirements into machine code? Am I going to use a for loop? Am I going to use a while loop? What constructs do I apply? Whereas an experienced developer already sort of feels these things. They know, like, oh, this should be a for loop. Oh, this is how I translate these requirements into machine code. It's if, else, and, well, don't use else, by the way. Ooh, different topic. They know what they want to do. Has anyone read this book? Thinking Fast and Slow by Daniel Kahneman. Raise your hand. Oh, there are some people. Okay. Did you finish reading the book? All right, a lot of hands dropped there. I did finish it. I pushed through it, but it's a pretty interesting topic. It's about a lot of psychology, and one of the things that he talks about is System 1 and System 2. Now, for the people who've read the book, they will know about System 1 and System 2. So System 1 over there is your fast and intuitive system. It's where your reflex comes from, like your initial reaction to things. It's where your emotions live. And then System 2 is your slow and conscious system. This is where you need to exert mental energy to be able to do something. So if we go back to our little driving example, the beginner driver is still very much in their System 2. They're very effortful and conscious about what they're doing, right? But the more they do it, the more hours they put in, the more they'll move those things to System 1. System 2 is generally lazy because it requires mental energy. So it's usually like System 1 will come up with like a first sort of reaction, and then if you're not too tired, System 2 will check that reaction and be like, yeah, this is fine, or probably shouldn't say that, or probably shouldn't do that. So you can imagine that as a developer, if you're more of a beginner developer, you'll be in System 2. It becomes very tiring after a day of being in System 2, right? It costs a lot of mental energy. So that's also sort of a moment where you become less of a great decision maker because you have less space to think about things, right? You're too focused on all the sort of mechanics of things. You can't think of the broader picture. So, how do you become a better decision maker? Just put in more hours. There you go, talk finished. That'll be easy. We can actually help people who are still very much operating their System 2 and programming. We can do this by using standards. Ooh. I'm not talking about the code style standards, even though they're also very useful and should be applied. But I'm talking about sort of architectural standards. Imagine, let's go back to our driving. Imagine you're driving on the road, suddenly no traffic rules. I was going to make a joke about the roads and the traffic here, but I shouldn't do that. No traffic rules. You approach an intersection and there's a car coming from the right. But since there's no traffic rules, you don't know whether to give way or take way, so you're sort of communicating with the car on the right, being like, all right, should I go? Do you go? And it becomes very chaotic and very annoying. So this is why traffic rules are actually useful. Aside from safety, it becomes a lot easier to drive because there's expectations. You know what to expect. There are rules. I think my watch thinks that I'm doing a workout right now. It just vibrated like crazy. So you know what to expect, right? You know when a car is approaching, you're like, okay, they're coming from the right, I have to give them way. And this is exactly the same thing that helps beginner developers navigate a code base and sort of alleviate the system to a little bit for them to focus on other things. Right? So creating those architectural guidelines or like naming conventions or whatever you can do to sort of like standardize really helps beginner developers. It helps them become better decision makers because they can focus on what is actually important, what this change, the impact of this change on the entire code base. All right, let's move on to a more serious topic. What do these two people have in common? Glasses? Yeah, it's weird. Like, I keep forgetting Peter Griffin is actually wearing glasses. Like, it's just like one little line here and one little line there, but for all I know, it could be his eyes. Sorry, you said? Oh, you're so smart. You're so smart. So yes, they are wearing the same clothes. Now, the reason that they do this, well, the reason Steve Jobs does it, I don't know why Peter Griffin wears the same clothes every day. Maybe it's a lazy cartoonist or, probably just his image. But Steve Jobs does it for a particular reason. Does anyone know why Steve Jobs does it? Branding? Paparazzi? Sorry? He doesn't have to think about it? I think more people were saying the same thing. Yes, exactly. So he's trying to minimize the amount of choices that he makes throughout the day. Now, I'm not suggesting that you should do that, unless anyone here who's like a Steve Jobs sort of billionaire kind of person. I want to talk to you after the talk then, please. No? Okay. So my point is not wear the same clothes every day. I mean, you should just wear unironed shirts. It's even better. But it's about decision fatigue, right? And it's good to realize that when you're tired, you're not the best decision maker. So when that colleague comes up to you, or a friend, your boss, or a client, it's okay to say, hey, it's been a long day. I'm tired. I'm probably not going to make the best decision right now. I'm going to sleep on it. I'll get back to you tomorrow. And realizing this is very important. And even like sleeping on something, your mind does crazy things when you're not consciously thinking about something. It solves a lot of problems. Let's move on to quality of decisions. All right, how do I put this? We're going to go back to our car. Just imagine we're driving that nice Corvette, or electric car if you prefer an electric car. Is there an electric Corvette? Probably not, right? Nobody knows. Okay. So you're driving, you're approaching a traffic light. We have traffic rules, by the way. It's okay. You're approaching a traffic light, and the traffic light is red, and you decide to still drive through it, and a car hits you from the right side. Good decision, bad decision? Good decision? Okay, thank God. Bad decision? All right, good. All right. Thankfully. Okay, now imagine the traffic light was green. You drive through it, you get hit from the right side. Good decision, bad decision? Good decision? Bad decision? Ooh, that's cool. Some people said bad decision. Anyone want to explain why they think it's a bad decision? Exactly. I'll repeat it for the live stream. You still have to look at the environment, because if the road was wide open and you're able to see the car coming, then yeah, you should pay attention. You should still check to see if there's a car coming, even though the traffic light is green. Now let's say the traffic light's green, you drive through it, and a piano falls from the sky on top of your car. Good decision, bad decision? Good decision. Bad decision. That's very realistic. Come on. Bad decision. All right. Everyone says good decision. The point is, there is a point. The point I'm trying to make is that it's important that when you're making a decision, it being a good decision is all about gathering all the information that you need. If there was information readily available for you and the outcome of your decision turns out to be bad, then the decision was probably bad because that information was right there. If you just had to look a little bit further. Now, a piano falling from the sky is quite unlikely, unless you see a crane as well, and okay, whatever. But things can happen. Just because the outcome was bad doesn't mean the decision was bad, right? You can't always know. So, one thing I like to do is when we're making a decision, It's important to be able to pivot for when it does end up being a bad outcome. So I call this coding for change. And we know a bunch of design patterns that we can apply to do this. We have our adapter pattern. For example, fly system. People know fly system? You know fly system? Yeah? All right, if you don't know fly system, it's about a quarter of people that raise their hand. If you don't know fly system, it's about, it's basically an abstraction for your file system. So let's say you're going to rely on local storage for now. Then there's an adapter. You can swap it out for an adapter to rely on S3 storage or Azure file storage or, God, there's so many storages. I don't know, DigitalOcean spaces. You can sort of swap those out easily without having to change your implementation, which is really nice. And this is what I mean when you're coding for change. You made the decision to use local file storage, but if you use fly system, you can swap it out, and you can still rely on some cloud storage instead, if that becomes your requirement. Hexagonal architecture. There was a talk about hexagonal architecture here, right? Yes. So hexagonal architecture, another great example of sort of isolating your domain logic, your business logic, and your infrastructure just being around it, and you were able to swapping out your infrastructure. Really allows you to pivot later on in a project as well. And of course, Rector for refactoring. So Rector is a tool for automated refactorings. If you made some sort of decision and later on you're like, no, it wasn't a good decision, now it's all over the code base, you can use Rector to sort of automate pivoting from that decision, using a different sort of implementation instead. All right, let's make it a bit more concrete. Decision-making techniques. Full disclosure, I don't actually use this method. Not very often, at least. But I figured it'd be good to tell you, because if you do get lost, if you do sort of feel lost in everything that you need to do, it's good to sort of fall back onto these 7 steps of effective decision-making. So you've gone through all of these steps, and you've covered all bases. So that's why I'm sharing it with you today. So the first step is identify the decision. Make sure you have a clear picture of what you're deciding on. Should we refactor this piece of code? Yes or no? 2, gather, whoops, I just punched the mic out of my pocket. Gather relevant information. Just like we said with the car example, when you're approaching a road, you need to make sure that you have all the relevant information available to you. Is there a car coming from the right side? Is there a piano coming from the sky? Right? And I'll give you some more examples for gather relevant information. For code, this could be either some code metrics, or maybe churn rates. Churn rate is how often does this piece of code change. It could be business value. And these are all good factors to include when deciding on this, on whether or not you should refactor this particular piece of code, for example. Then we have identify the alternatives. Remember system 1, system 2? System 1, if you heard of a thing called programmer's intuition, right? It's a real thing. It's something that you practiced. It happens when you've moved so much from your system 2 to your system 1 that it becomes your intuition. Like you just sort of know the right answer, you think. It's mostly right. Like it's mostly trustworthy. And this program intuition is really strong. It's perfectly good to rely on it for most parts. But it is also good to push yourself and to identify more alternatives than just that first option that comes to mind. Even though the first option is probably the best one, please push yourself to think of 1 or 2 more. Now weigh the evidence. Which one's better? This will be a fun discussion. Pick one of the alternatives and implement the decision. And then number 7, review the consequences. Like we use, I see everyone going like this. It's there, everything, all the steps. 7, right? Yeah, 7, great. So it's also important to review your decision, right? Because we do sprint retrospectives, but do we actually talk about our technical and code decisions in those sprint retrospectives? Like they're more sort of process focused, right? So what you could do, for example, is do a technical retrospective instead. Talk about your code. We'll get back to this later. Another one, we have pre-mortem. So this is also from the book, Thinking Fast and Slow. And it's by Gary Klein. Gary Klein is an expert in naturalistic decision making. So so decision making in like a natural, normal environment. And they say, before a formal decision is made, imagine we are a year into the future. We implemented the plan as it now exists. The outcome was a complete disaster. Please take 5 to 10 minutes to write down a brief history of the disaster. This really unlocks some creative destruction in some people. Some people love doing this. I am not that person, but some people love doing this. People know that pessimist in their team, like the one who always sees problems down the road? Yeah? People are afraid to raise their hand because their colleague is here. You're sitting next to me right here. Those people can be annoying sometimes, right? You come up with this idea and they're like, no, it could, raise condition here, that could happen, the database could go down and then everything would blow up and you're like, come on, it's never going to happen, it's fine. As annoying as it sometimes is to have those discussions, it's very valuable. I always make sure I have at least one of those people in my team because I want them to challenge me. I want them to see all those problems and I want to talk about them. I want to make a conscious decision like, hey, we knew these were risks, but we still took this decision, right? So this works for some people, and for some others it just doesn't. All right. Let's talk about decision making within a team. About 5, 6, 7, 8 years, I lost track of time. Some years ago, I was in a team, we were building a platform for a telecom company. It was quite a big team, about 6 developers, 2 testers, 2 product owners. At least I think that's quite a big team. I know there are bigger teams around there, of course. And at some point, the lead developer at the time got sick. And I was appointed as the new lead developer. And I was still pretty inexperienced. I didn't really know what to do. It was my first time being a lead developer, so it was quite an interesting time. Suddenly, you have to make a lot of decisions. Like, everyone's like, oh, what are we going to do now, Rick? You tell me. Like, oh, geez, okay. So naturally, this decision-making framework started to form. I wasn't like, oh, you know what I'm going to do? I'm going to do a decision-making framework. No, it sort of naturally grew from the things that were coming my way. And I want to take you through this framework. So, the very first thing on that framework is decide who is responsible for the final decision. Now, this is typically the lead developer, and it's important to realize that the lead developer is responsible for the final decision, but they don't have to make the decision themselves. It's about facilitating the team to get to a conclusion that works for everyone, right? Number 2, give them pseudo rights. Now, if you're not familiar with a Linux setup, in Linux you have a command called sudo, which means super user do, and it gives you sort of the highest elevation of privileges to execute a command. But what do I mean by this? I don't mean literally give them pseudo rights on the production servers, which is fine if you want to do that. But this is about merging things. You know those pull requests or those merge requests that just end up in sort of like this endless discussion? Sometimes it's better to just make a decision than not making a decision. Even though you're not sure, just remember code for change. But if you're not, sometimes it's just better to continue moving than to stand still. So we decided we're going to give the lead developer pseudo rights. So if that happens, that person can say, you know what, F it. I was afraid to cuss on a live stream. You know what, F it. I'm going to pseudo merge this. There you go. And we all agreed to this. So because everyone agreed on it, it was never really a discussion. A decision is easier made with 3 developers than with 2. If who was here in 2017? phpday 2017. Did you see my code review talk? Do you remember? No, I'm not going to ask you if you remember. Do you remember the one slide? No, I'm kidding. But in that code review talk, I also talked about decision being made easier with 3 developers than with 2 developers. Because with 2 developers, you have sort of a side A, and you could have a side B. So when you have a merge request, there might be a discussion like, oh, let's do this. And like, no, let's do this. And we decided that as soon as this goes back and forth once, that we're going to call in a 3rd developer and hope that 3rd developer doesn't introduce a side C, right? Because that would be a bigger problem. But most of the time, it would be fine. Most of the time, they would say, all right, let's go with side B. And we were okay with this. Because again, it's important to keep moving forward because as much as we as developers think some things are important, like tabs versus spaces, tabs for the win. No, I'm joking, spaces. As much as we think that it's important, it's not always as important as we think it is. Sometimes we're too much behind certain principles, and if you look at the business isn't really going to care. And the code base may only be marginally different, like better is still to be discussed. Now, of course, some things are just more important. You can always escalate them and have a proper meeting about it and talk about it and have a good discussion about it. But this is how we would navigate most of the small decisions, the micro decisions that we're making. As a lead, involve others into the decision to create support. Now, support, I'm not sure if the word support is the good. We have like 3 Dutches here. Draagvlak is what I'm looking for. Yeah, try pronouncing that. Good luck. Draagvlak. So it's about creating support, making sure that everyone's involved in a decision. Because when everyone's involved and everyone has had their say as well, and they know the process of how you got to this conclusion, you have a lot more support. People are on the same page, they know what went through it, and they were able to give their input as well. There's nothing worse than someone being like, all right, I'm going to isolate myself, and I did some research, and I got the solution. We're going this way. And then everyone's like, how'd you get there? Like, why? This way's better. And he's like, no, I know because I did all the research. Like, what research? It's good to involve others. It's very, very important. This is how you create an autonomous team. And the same for this next point, creating a shared technical vision. If everyone knows what you're trying to achieve, if everyone knows that dot on the horizon that you want to go to, and you're standing here and you have to make a decision, then they know, oh, if we make a decision that's more pointed towards this way, we're getting closer to the dot on the horizon, right? It creates autonomy in the team, and reiterate it often. A great developer once said, it's a lead developer's job not to decide, but to facilitate the decision. I can't stress this enough. All right, let's talk about documenting decisions, right? Some people are like, I didn't pay attention. Why are you laughing? Let's talk about documenting decisions. It's a very sexy topic, right? We like documenting decisions. Anyone who likes documenting decisions? Or documenting in general? Well, that's still more hands than I expected. Nice. Yeah, so documenting decisions. There was a project that I was doing, and I saw on Twitter, I refused to call it the other name. I saw on Twitter that people were documenting their decisions. And I was like, I don't know why, but let's do it, right? I had this Greenfields project. I was like, all right, let's make this decisions.md in my project, and screw it. I'm going to write down whatever things I'm deciding now. I'm going to use this framework. I'm using this particular bundle. We're relying on GraphQL, so I had found a GraphQL bundle that worked for me, and I wrote down like why I picked it and everything, and I wrote down some other decisions. I left it for like a year, and I was like, I'm not really doing anything with it. But at some point, we ran into some issues with that particular bundle, with that particular package. And I was like, why did we pick this package? Why? It's so annoying. But it's really hard to look back and think, like a year ago, this is what the ecosystem looked like. Right? It's really hard to imagine that. And it's also hard to remember the considerations you had back then, because they may have changed. Like your requirements change over time. So when I looked back and I looked at my markdown file, I could see like, oh, this is why we did that. That other package didn't even exist at the time. So documenting these decisions really, really helps. Definitely when you're dealing with long-running projects, because we all know that feeling when you're joining a project and you're like, oh, why was this decision ever made? This was the worst decision ever, right? So you'd like to be able to read up on it and figure out why it was done. One way of doing this is ADRs, architectural decision records. I'm sure most people have heard of the term by now. And this is an example template. You have the title over there. You have your status. Let me just scroll down for you. Oh, I should probably scroll on this screen. You have context, decision, and the consequences. Now, pick whatever works for you. This is tricky, right? It's tricky to do this in your workflow and to do it consistently. So I don't care if you do it on Confluence, I don't care if you do it in a wiki or in Git, it has to work for you. It has to be something that you're like, all right, I'm going to go ahead and update these decisions. Like if it's in Git, you could make it part of your merge request, or if it's in Confluence, it's more accessible to maybe project managers and such. But do it in a way that works for you. Also, if you don't want to have this entire template, if you just want to have like one paragraph in your decision, also fine. If that is something that you can keep up with, if that is something that you can keep doing, then choose that. I'd much rather have that than this very elaborate template that's hardly being updated and is hardly being iterated upon. So let's add it to our decision-making framework. Point 6. This is the last point of this framework. If you want to take another photo, then now is your shot. Do we have any chess players here in the building? 4, 5. There's a few. People are like, well, I know the pieces. Who started playing chess around the COVID times? Queen's Gambit. It got really popular. Yeah, they're like half of the people that raised their hand. That's really cool. Really cool. So let's talk about chess. So in chess, you have 3 phases of a game, right? You have the opening phase where you develop your piece a little bit. You push your pawns, develop your knight, your bishop. Then you have the mid-game where you maybe create some attacks, you capture some pieces, hopefully, or you trade some pieces, or maybe you just improve your defenses. And then you have the end game. This is where a checkmate, or if you're an chess player, it might be stalemate, is one of the outcomes. Now, chess players need to have a few crucial skills. We're going to talk about 2 of them. In chess, it's very important because when you're playing a chess game, a competitive chess match, there will be a clock. So you do the move and you hit the clock, right? And it's very important to do good time management here because you need to make sure that you don't end up with a lot of time at the end or too much time at the end. This may sound counterintuitive, but if you end up with too much time at the end, it might mean you haven't invested enough time in your mid-game and your opening to create a better position for yourself. So as chess players, you're constantly working on time management. You'll see this with beginner chess players very often. I've taught some kids, like 6-year-old kids, and they have a clock and it's like, like they have like 10 minutes left at the end, right? It's like, no, slow down, think about your moves. They're like, still fast, but whatever. They're trying. They're 6 years old, it's okay. So time management is very crucial. But how do you know when to invest that time into the right move? How do you know when you should spend some more time thinking? This is what we call recognizing critical moments. And this is a very tricky thing because you might think that in your game, the critical moment was the point where you lost a piece. But this is mostly wrong because the critical moment was a few moves before that. It's when you got yourself into a position where you had a bad move where you could lose a piece. It's usually a few moves before that. So being able to recognize these critical moments helps them know, like, okay, I should invest more time into thinking about the next move I'm going to do because I need to make sure I'm in the right position. And we have this as developers as well. At some point, your code base might end up a little bit janky. Things happen. Suddenly you have a God class, a class that has too many different behaviors. And you might think, oh, it went wrong as soon as we added this behavior. But it could also be that the class was named wrong, inviting people to add behavior. It wasn't supposed to be there in the first place, right? And being good at recognizing critical moments, I think sometimes people ask, like, okay, how do you know when to sort of sit down with the team and make sure you make the right decision? It's all about growing this intuition. It's all about teaching that system one to throw up a little flag when something happens and be like, hey, this is an important time. This, you did this other project. This is an important time. Now you need to sit with the team and really think about what you're going to do now. But how do chess players do this? How do they train this critical moments skill. How do you think chess players practice this? Anyone want to take a guess? They have to think a couple of moves forward. So yeah, absolutely. They're constantly thinking what's going to happen in 4 or 5 moves from now. True. But how do they... Exactly. And how do they recognize those patterns? It's because... Sorry? They do puzzles. Very true. They do puzzles, and at the same time, they also keep score. They keep track of the games they played, and they analyze those games, right? And it's this combination of puzzles and analyzing your previous games and recognizing those patterns that helps them train this skill. And it's funny because I mean they keep after every move they write down the move they did, and afterwards they can still play the game by heart. It's weird. Chess players are funny like that. But it's this practice that we are not getting as developers. I feel like when have we ever sat down and sort of gone through our code or the lifetime of our project and went like, hey, this was a critical moment. This is what we missed. You know, we're so busy looking forward. We don't really look back at our code and how it all started. So this is why I think those technical retrospectives really come in. And it's not so much about the outcome of these retrospectives. It's about doing them, right? It's about the practice. It's about teaching that system, one, to flag up when something happens, right? Just getting those patterns ingrained into your brain. Now, one way to do this technical retrospective, this is sort of a free form, like whatever works for you. But you could do, what you could do is you could use something like PHP metrics. And you can take a point in time. I see Derek looking very puzzled at the screen. You can take a point in time in your code, maybe 3 months ago, maybe also 6 months ago, or a year ago. And you can take snapshots with PHP metrics and look at how your code base sort of grew and what the relationships were between classes. And maybe one class started to sort of grow and become very important. And it's doing this exercise that helps you and talking about it. All right, the takeaways. First, experience really helps. More experience makes for a better decision maker. Training your system, one, more space in your system, two, to think about the bigger picture, the bigger impact of a certain change. 2, the 7 steps to effective decision making. If you ever feel lost, you don't know what to do, maybe it's overwhelming, just go through the 7 steps. Just go for them step by step so you know you do all that's necessary to get to a good conclusion. 3, create a decision-making framework within your team and agree upon it. Make sure you create this as a team, you agree upon it as a team. That way there will be no discussions. We can just point to the framework and be like, this is how we do things. It creates efficiency, it creates autonomy. 4, document your decisions using ADRs, or whichever way works for you. And 5, analyze previously written code and get better at recognizing those critical moments. Thank you.
Thank you. Thank you, Rick. Now I will always look up when I'm still at the traffic light.
Yeah, watch that. The piano is coming for you.
Yes. So I think we have one? No. We have no questions. We have a question actually. I think it was a keynote. No questions, but no. If you want.
Yes. Go ahead.
Yes. You're speaking about the system 1 and system 2, and for decision, for example, you start a project, you use Symfony, you use MySQL, and you go on. At which moment you use your system 2 to say, oh, maybe I should use Postgres? What could be the cling to say, hey, I need to change the decision I always made?
Yeah, this is so your system 1 and system 2. It's for example, what's 1 plus 1? All right, that took you a little bit longer than expected. It was like 2, I think. All right, if I gave you a more complicated sum, like what's 56 times 45? There you go. Okay, so this is where you're engaging your system 2, right? You're going through those steps. So it's more of a response to the questions you get asked. So that's why it's important to recognize those critical moments so you know when to ask yourself that question and to trigger that system 2. And this is it's so hard for me. I can't give you a very clear line on like when you should do this because this varies so much between projects, right? This is a very sort of difficult thing to grasp, but it's all about training that experience in yourself and making sure you have that reflex at certain points. And you will, because at some point you will make this big mistake and be like, oh, that project really went bust because we went this way or went that way. And that is a teaching moment. That is when you really ingrain into your brain like, oh no, we really should have sort of made this decision different or really put more time, the whole time management thing, put more time into this decision process. But yeah, it's a matter of experience. So it's kind of hard to give you a clear and concise thing of doing it. Yeah.
We have other questions? No. So thank you, Rick.
Thank you.
And I think now we can welcome on stage Rob Allen.